Hello geometry students. Getting ready for the Chapter 7 practice test. Here's the algebra review. The most important thing to remember about these fractions, even though they are more complicated than what you're used to seeing, is that the same rules that applied in elementary school when you learned about fractions apply to these as well. I'm doing x over 3 minus x over 4. If I subtract two fractions, I need a common denominator, as you know. So you have x over 3 minus x over 4. What would be the common denominator for these two fractions? I'm sure you're thinking 12. That'd be a good choice. So remember how we changed these into fractions with the common denominator of 12. 3 times 4 would make 12. Whatever I do to the bottom, I have to do to the top. So 4 times x is 4x, and 3 times 4 is 12. So now I have 4x over 12. Alright, let's take care of the second fraction. I have a 4 for a denominator, so I turn that into a 12 by multiplying by 3. Whatever's done to the bottom must be done to the top. 3x over 12. Remember, in subtracting common denominators, don't subtract the denominators, or fractions with common denominators, don't subtract the denominators, but you knew that. 4x minus 3x is 1x, so it's just x over 12. Alright, the second fraction, it's multiplication. So when we do multiplication, that's the easiest operation to do on a fraction in most cases. So you have x plus 4 over 10 times 5 over 2. Now here's what I would do. I would recognize this fact that I have a common factor between this numerator here and this denominator. 5 goes into both. 5 goes into 5 once. 5 goes into 10 twice. Now I have an easier problem to multiply. X plus 4 times 1 equals x plus 4. 2 times 2 equals 4. Now remember, in this case you cannot divide the 4's because you have this addition in between. Okay, so that's your answer. X plus 4 over 4. Now what if you didn't like doing it that way? If you didn't like that, you would do distributive property up on the top. I'm going to change the order of these. 5 halves times x plus 4 over 2 times 10. Alright, 2 times 10 is 20. And then 5 times distributive property, 5x plus 20. Now remember, on this x plus 4 divided by 4, we couldn't just divide 4 because we'd have nothing to do with the x here. But in this case, all three terms have a common factor of 5. So you could divide each of them by 5. 5x divided by 5 is x. 20 divided by 5 is 4. 20 divided by 5 is 4. So you see, you end up with the same value right here. So that's how that one works. And the next one. When you divide fractions, we do not divide by fractions. ABC buttons on calculators are the worst invention ever made for division of fractions because they make you think that you just go 7ABC3 divided by 3ABCX. Oh, it won't do that, will it? That's why we have to remember that when we divide fraction, we change the operation to multiplication, and we change the second fraction to its reciprocal. Remember that word? Reciprocal. 3 over x, its reciprocal is x over 3. And now it's just like the one we did before, except a little bit easier. It's just like b, it's multiplication of fractions. 7 times x is 7x. 3 times 3 is 9. No way to reduce that, so that's your answer. 7x over 9. Alright, now for the last one. This is a little bit more complicated than most of the ones you've seen so far, as I'm sure you know. Alright, this is where we must remember that when we factor things, good things happen. And I'm just going to put this first fraction. You can see you have subtraction as the operation between, which means I need a common denominator. So the big question is, how do I get x squared minus y squared to be the same as x plus y? Here's how you do it. You factor the numerator and the denominator. It's pretty easy to see how to factor the top. They both have 5, so I can take the 5 out, and that leaves me x minus y. Alright, so that's 5x minus 5y factored. How do you factor x squared minus y squared? Well, the key to that is recognizing this as a difference of squares pattern. I have a perfect square value for the first term, perfect square value for the second term, and subtraction in between. That means that this is how it factors. X plus y times x minus y. Remember, this is that one where when you FOIL it, your terms in the middle are opposites of each other, so they zero out, leaving only the x squared and the y squared, the minus y squared. So only the f and the L of FOIL remain after we FOIL that. Alright, how does this help us? Well, now that we factored it, you can see that I have x minus y over x minus y. That makes 1, so I can cancel it out. So now I've turned this whole first fraction into just this part. Oops. 5 over x plus y. Well, now let's go back and look at the second fraction here. Surprise, surprise, surprise. The denominator is x plus y. So we have our common denominator. We did it by factoring. So we have 5 over x plus y minus 2 over x plus y. Common denominator. So we just keep that common denominator and do the indicated operation on the numerator. 5 minus 2 is 3. Then it becomes a piece of cake to do that. But if you're going to do that successfully on the test, you have to recognize what to do with this fraction. You have to see that you got a factor. You have to see that this is a difference of squares, and it factors this way. X plus y, x minus y. If you don't see that, you'll get it wrong. And I don't want you to get it wrong. Neither do you want to get it wrong. So that's the algebra. And I'll see you on number 2 with the true and false questions next. A couple tricky ones in there. So you'll want to be there for that.